In this video, we're going to be talking about unbalanced forces. We're going to work out two example problems where we see a scenario where something has forces that are unbalanced, which causes it to accelerate. If you can see off to the left over here, we have two problems, and off to the right, we have two very, very similar problems. For the first half of the video, we're going to be breaking it down a little bit more simply with just the diagram and then just plugging the values in right into our diagram. For the second half of the video, we're going to break it down in a lot more detail. We're going to show the sum of forces in the X and Y direction and show a little bit more of like the specifics and do something a little bit more complicated with our second problem here. All right, so first of all, we're going to use F net equals ma, which is basically Newton's second law. And when the forces are unbalanced, that basically means that your net force does not equal 0 newtons. So if you take all of your forces and combine them together, consider their directions, they will not cancel each other out. There's basically going to be some leftover force, which is going to cause your object to move and accelerate. All right, so let's take a look at our first picture. We have something that is falling. So we have an FG pulling down as usual. We typically don't consider air resistance that much, but in this picture we will because it's someone falling with a parachute. And then from there, we know that the air resistance is 200 newtons because it's written in the problem. And then for the bottom part, we are going to do Fg equals mg, which is mass, times 9.8, and that equals 490 newtons. So from there, basically what you want to do is you want to identify which direction is your positive and which direction is your negative. It actually doesn't really matter which one is which, but I would say it's pretty common to say up is positive and down is negative. So your net force would be 200 newtons minus 490, which equals negative 290 newtons. And then from there, you can set that equal to your MA and solve for your acceleration. All right, so we got a final acceleration of negative 5.88 meters per second squared, which sounds pretty reasonable because if it was in free fall, it'd be negative 9.8. So we're definitely looking for something in the range of 0 to negative 9.8, which we did. So it sounds like a pretty reasonable answer. For our second diagram, we have a little bit more going on here. As usual, we're going to draw our diagram. We have Fg pulling straight down as usual, Fn pushing up perpendicular as a surface is supporting it, Fa from the person pushing it, and Ffk, the force of static friction opposing the slide. So in the description here, it says there's a 200 kilogram refrigerator and it's pushed with 300 newtons of force and experiences 250 newtons of friction. What is its acceleration? Now, for this type of problem, you can sort of get away with not solving for anything in the vertical direction because all of the components that are going to affect the acceleration of the object are just in the horizontal direction. So we have an applied force, which is 300 newtons, and a force of friction that's 250. So again, you just kind of identify which way is positive and negative. We'll say everything that's making it go is positive, everything that's opposing it is negative. And then from there, we can go ahead and find our net force, kind of like what we did in the previous problem. We're going to take those two forces and combine them. We combine them by subtracting them because they're going in opposite directions. So we're going to take our 300, subtract our 250, and then we have 50 newtons. And then we are going to complete our calculation by setting our net force equal to m times a to see what we get for the acceleration. Okay, so we set our net force equal to our MA, so it's 50 equals 200 times A. We just went ahead and divided both sides by 200, and then we ended up with 0.25 meters per second squared as our acceleration. All right, so that completes our first part of the video, which is solving for an unbalanced force problem, the more basic version where we just kind of put our numbers right in our diagram and then just went with our F net equals MA to solve our acceleration. Now, if you want to listen to the second part, now we're going to do a more detailed version of where we do the sum of forces in the X and Y direction. So our first step, as usual, is to draw our force diagram. So I'm going to go ahead and draw that pretty quickly because we've already done that off to the left. All right, so from there, we're going to do something a little bit different than we did the first time around. We're going to sum up our forces in the X and Y direction. So I'm going to take a look at all of the forces that are going in the horizontal direction here, which we don't have any. So we actually don't need this for our first picture, but a lot of times you will. So we're going to sum up our forces in the Y direction. So we're going to call up positive and down negative. So we'll say the sum of forces in the Y direction is the air resistance minus our Fg, and the sum of our forces, which is our net force, always equals m times a. And then from there, we're just going to go ahead and plug in our values and then say that air resistance is 200 newtons as given in the problem. Our Fg is mg, mass times 9.8, and that equals our mass of 50 times a. Okay, so we're going to go ahead and work out that math as we did earlier, and then we will get negative 290 equals 50a, and then divide both sides by 50. All right, for our second problem, it definitely gets a lot more complicated than what you just saw there. So now we do actually have to sum up a bunch of forces in the X and Y direction. So again, I'm going to call upwards positive and down negative. And then I'm going to call FA my positive because that's in the direction of the movement. And then my FFK as a negative because that's opposing the slide. So now I'm actually going to have two formulas where you're going to have applied force minus force of kinetic friction. Your net force in that direction equals m times a. And then the same thing over here, except with our vertical forces, Fn minus Fg. And that equals m times a. In this last problem, we're going to need a new formula, which will come into play a little bit later, which is our friction formula. The friction formula equals mu times Fn, which is the coefficient of friction, times your normal force. So what I'm going to do is I'm going to go ahead and plug in all the numbers I know and see where that leaves me and see if I'm able to solve for the acceleration. so I have completed my sum of forces in the x and y direction. For the sum of forces in the x direction, we had our Fa as given in the problem. We didn't have the force of friction, so we had to break it down further and use that formula mu times Fn. We had the mu value, the zero point 0.2 right here that we plugged into the formula. I did not have Fn, so I just went ahead and just put the variable there, equals the mass times acceleration. So then I just left that as is and went over to the sum of forces in the y direction, and then we still don't have Fn, so I put Fn minus my Fg. Our Fg is mass times 9.8, and that equals 0. The reason I knew that was 0 is because there is no movement or acceleration in the vertical direction, so therefore it's pretty safe to say that it's 0. As we worked through the problem, I could see that the only unknown variable is Fn, so I knew that my normal force could be calculated, which it came out to be 1,960 newtons. And then from there, now I'm noticing that the Fn that I didn't have before, I do now have after using all of my numbers in the sum of forces in the y direction. So I'm going to go ahead and plug that in and finish my problem off. All right, so I went ahead and plugged in my 1,960 for my normal force. So when I am able to multiply my 0.2 times my normal force, that gave me my force of friction, and then I subtracted that number from 500, which gave me 108. 108 equals 200 times A. I finished off by dividing by 200, and my final acceleration came out to 0.54 meters per second squared. All right, so as a quick sum up, what I did is I made sure I created my force diagram first and foremost, made sure I identify which direction is positive and negative along my x-axis and my y-axis. And then from there, I'm able to create a formula based on my diagram for the sum of forces in the x and y direction. Once you get to that point, you plug in all the numbers that you know that you've calculated or that have been given to you in the problem, and you basically work out the math from there to solve your final solution. Thank you for watching and listening.